Hello everybody, welcome to the homework help video for 411. I'll be going over problems 7 through 11. Alright, so let's get started. In 7 it says to solve the equation graphically, that is graph it. So let's go ahead and do that on our graphing calculator. We're looking for, it says y is equal to the quantity x minus 2 squared and minus 3. And we're interested where it's equal to 1. So what I'm going to do is I'm going to set a second equation, which will be my red line for where y is equal to 1. And then I'm going to go ahead and change my zoom and graph it. So my function's in blue, and then where y is equal to 1 will be in red. And so it's telling us to solve it graphically by looking at it. What we really want is the intersection points. So I'm going to do the command. I'm going to go second trace, and then I'm interested where it intersects. And then I want to get that dot to where my red and blue line intersect, which looks like for this one we're pretty close to. So my first intersection point is at 0, 1. So one of the answers for when y is equal to 1 is 0. We also can see that it's going to intersect at a second point. So let's go ahead and find that one. And scroll over and get as close to where that intersection point is as possible. Nope, too far. Okay, so we find out that our intersection point is also at x is equal to 4. And so two answers to this question is x is equal to 0 and x is equal to 4. So after we solved it graphically, it says then use algebraic strategies to solve the equation to verify that your graphic solutions are correct. And so this is what we were doing in class. 4.7 is really just like what we did in class on Monday. So we took and looked at it graphically, so we know our answers are 0 and 4. So let's see if we can come up with at least one way to algebraically prove that that is the case. So I'm going to rewrite my equation in this empty space. Whoops. I want to make sure that I've got my start board up. So we've got x minus 2 squared minus 3 is equal to 1. What I'm going to do is get rid of that 3 from the side with the x. And I'll have x minus 2 squared is equal to 4. So I'm going to take my square root. So we know that x minus 2, I'm going to take that outside of the parentheses, is going to be equal to two things. It's going to be equal to, we know that the square root we can multiply by 2 and negative 2 squared. So x, I'm all over the place right now. X minus 2 is equal to 2, and x minus 2 is equal to negative 2. We'll end up adding 2 to both sides, and we will have successfully verified that x is equal to 4 and x is equal to 0. So check that out. So again, just showing you that there's multiple ways to solve something. We can look at the graph and we can also do it algebraically. Alright, then in 4.8 says to solve each equation below, think about rewriting, looking inside, or undoing, simplifying process. So with these, we're interested in just solving them. But kind of trying to think if there's different ways to solve it. Remember the theme that's kind of running through this is there's different ways to do the same thing. So I'm going to solve it one way, but maybe you see it a different way. So for this first one, we've got 2x, 2 times the quantity, x minus 1 squared, plus 7 is equal to 39. So I'm going to go ahead and subtract 7 from both sides, leaving with me 2 times x minus 1 squared is equal to 32. And I'm going to divide everything by 2, leaving me with x minus 1, the quantity, squared is equal to, that should be 16. So we take the square root. We're going to get that x minus 1 is equal to 4, and x minus 1 is equal to negative 4. Write that. So if we take and solve it by adding 1 to both sides, we find out that we have two solutions. That'll be x is equal to 5 and x is equal to -3. We'll do at least one more. So one you might have a question about is maybe C. So let's go ahead and try C. With this one, this is a problem with common denominators. And so we have x over 2 plus x over 3 is equal to 5x plus 2 over 6. So one of the first things you might think about is doing a cross multiplication. But before we do that, we want to add together the left side first. So we're going to need a great common factor for the bottom one. We know that 6 will be a great common denominator. For this one, we have to multiply this by 3 over 3, and this one by 2 over 2, which is going to give us 3x plus 5x is equal to 5x plus 2 over 6. So over here, this is going to simplify. My 3 plus 5x is going to give me 8x. So I've got 8x over 6. And what's really kind of cool about these problems is because now they're both over 6, you can actually eliminate the denominator. Another way you could do it is do your cross multiply and then solve. But I'm going to choose to do it this way. I know that the denominators, because they are the same, are now irrelevant. And so I will solve it by subtracting 5x from both sides. Getting 3x is equal to 2. And so x then is equal to 2/3. That one especially has tons of different ways you can do it. Really what you have to be careful of is that you're following your order of operations. And again, our answer was 2 over 3. All right. So hopefully those are fun ones. All ones you should be able to solve, but maybe it's been a while since you've solved those problems. If you have any questions about them, you can definitely check the answer key to see if you're getting them right. Otherwise, come in for help, and I will be happy to go over some of them with you. 4-9, it says, find the equation of the line that passes through the 2 points, and then complete A and B below. All right, so we want to do, first we're going to write the equation. For this one, our first one is that we need to find our slope. So we know it's of the line. They tell us that it's a line that passes through. So we're interested in our y equals mx plus b. And so we need to find our slope. So we'll do our change in y over our change in x, y2 minus y1 over x2 minus x1. That's going to give us, remember, we have to do our y's first. That'll give us 2 minus 2 over 5 minus 0. So we're looking at 0 over 5, which we know is just equal to 0. What that's telling me is I have a flat line. If I were to graph it, if this is my axes, x and y, if we're interested in, if we were to think about even plotting those points, we'd have to go 0 over up 5, oops, sorry, 0 over up 2, and then over 5, 3, 4, 5, up 2. And so we've got a line, a horizontal line, that goes through y is equal to 2. So my equation should be y equals 2. What is the equation of the x-axis? So what they're really asking you to do in parts A and B is that we've got our axes, right? So this is our x, and this is our y. They kind of have different, you would almost suspect. So what they want you to think is that they want you to think that x is equal to 0 and y is equal to 0. But that's not the case. For this one, it's actually the opposite. So if I want to graph the x-axis, for this one, my x's will all have numbers. This is, 2, 0, -5, 0. Always, always, always your y is equal to 0. And then opposite, your x is equal to 0. So for here, we're going left to right 0 and up 3. Left to right 0, down 3. And so x is always equal to 0 on your y-axis, and for your y-axis, it's y is always 0. So thinking opposites. Just thinking about it might be a little bit difficult, but trying to graph it, picking points and plotting them is a really helpful way to look at it. All right. So moving on, we're looking at number 10. 10 says to solve the system of equations. Woo, system of equations. We've got something for x equals. That's telling me that I need to use substitution. So I'm going to do that. I'm going to plug in my upper equation, wherever I see an x, I'm going to plug in 8 minus 3y. I'm doing 2 times 8 minus 3y plus 6y is equal to 10. I'm going to take and distribute this 2 into everything inside the parentheses. That's going to leave me with 8 plus 8 is 16, minus 6y plus 6y is equal to 10. What you can see here is we have a negative 6y and a positive 6y. Those will cancel out. And we're left with the statement 16 is equal to 10. What that tells us is that because we have a false statement, the two lines are parallel. They're never intersecting. So with this one, there is no solution. All right. Looks like they have lots for us to do. It says to describe what happened when you tried to solve the system. We got a false statement that said 16 was equal to 10, therefore we have no solutions. Then it wants us to draw the graph of the system. What we can do is we could solve them for y and graph them, but we know that if there's no solution, what's really happening, in a very general sense, is that if this is your x and your y axes, we have two lines that never intersect. They go on forever and ever and ever, and will never touch. So, I'm not exactly sure where those lines would fall perfectly, but I do know that they never touch. They should be parallel lines. And see, how does the graph of this x system explain what happened in the equations? So, what they want you to understand is that there's a correlation between getting a false statement and having parallel lines. All right. Moving on to 11. I need to erase my board. So to classify the triangle with the vertices by finding the length of each side. Be sure to consider all possible triangle types. Include sufficient examples to support your conclusion. All right, so what we're doing here is we've got 3 points. So we're doing coordinate geometry, essentially. What we want to do is we want to have a grid in front of us and plot those points. So what I'm going to do is I'm going to flip back over. I'm going to write my points. A is the point. I'm going to have to do a little bit back and forth. A is the point 3, 2. B is the point -2, 0. And then C is the point -1, 4. And so what you'll need to do here is either pull out some graphing paper or make up your own coordinate plane. And then 2, 3, 4, 5. 1, 2, 3, 4, 5. I'm going to take and plot these points. So I'm going to make red A. We're going to go over 3 up 2. Plot the point. Make B green, -2, 0. And then lastly C, -1, 4. And we want to make the triangle. So I'm going to draw some straight lines. And we want to think about what kind of triangle that is. Seeing if we can find the length. So to find the length, what we're really interested in is using our distance formula that says that the distance squared is equal to your change in y's, so y2 minus y1 squared plus x2 minus x1 squared. What we're essentially doing is taking the difference and then doing the Pythagorean theorem. We're going to see if we have a special kind of triangle. What they're looking for are things like isosceles. That would be two sides are the same. We could be looking for, if we looked at their slopes, saying if we had perpendicular lines, if we had that where we had opposite inverses, we would then have a right triangle. So lots of different things for us to look at and investigate. But the heart of it, the first thing they want you to do is plot those points and see what it looks like. In 12, it says to examine the figures at the right and then visualize the figure for our nth one. Oh boy, we're going back to sequences, except this time we've got a picture for it. So how many cubes are in the fourth? How many cubes are in the first? So for this one, what I'm going to do is I'm going to count the number of cubes because that's the relationship we want. So I've got, this is a cube. Oops, my smartboard is gone. Put it on transparency. So, counting the number of cubes that we have. Come on. It's not allowing me to write, which is unhelpful. Sorry guys, bear with my smartboard as it tries to figure itself out. There we go. So I'm going to count the number of cubes that there are. We've got 1 cube. We can see that back cube is hidden, so that's 2. 1, 2. Here's a third cube. We've got this fourth one, fifth one, and the sixth one. So we've got the 6 in the first one, and the second one. How many are we looking at? Or sorry, the third. I'm going to do the same thing. I know that this all belongs to 1. This is another one, 2. Got that back cube, 3, 4, 5, 6. This is number 7, number 8, 9, 10, 11, 12, 13. This is all 1, 14. 15, 16, 17, 18. Wonderful. All right. So we want to investigate that pattern. Probably the hardest thing about that is we have to use a lot of spatial reasoning, being able to picture the cubes. For me, it really helps, as you can kind of tell, having to say this is a cube, this is a cube, this is not. So after we got them counted, we're interested in the relationship on how we get from 6 to 8. It says how many will be in the fourth, how many are in the first. So what we kind of want to do here is think about how it's increasing. We went from 8 to 16, and it looks like since we're dealing with cubes, we're probably doing something with multiplication. So I'm guessing we needed to multiply by 3 is our relationship. And so the fourth figure, I'm going to take 18 and multiply by 3, which is then 18 times 3 in my calculator is 54. So in A, my guess is that the fourth figure is going to have 54, and then I'm going to work backwards too. If I've got 6 in the second figure, I'm going to take my 6, divide it by 3, and so I think my first figure has 2 cubes. C, find the general equation for the number of cubes for any n and verify your formula with, in the case of n to the 1, and n equals 5. So my equation is, so I need a starting value. Right now I'm at 2. So I need to take my 2 and divide it by 3, which kind of gives me something funky. But I do need a starting value where n is equal to 0. So we're looking at the equation with a starting value of 2/3. And then my thing that I'm doing over and over again is I'm multiplying by 3. And so y is equal to 2/3 times 3 to the x. All right. With that, we want to verify for the n to the 1. So if I plug in 1 for x, I take 2/3 times 3 to the first, and that should be giving us 2, which it does. So excellent. Sorry, I realized I just checked that on my calculator and you didn't see me do any of the work. But I verified it works, and then I would just plug in for 5 for the next one. So y is equal to 2/3 times 3 to the 5th. 3 to the 5th times 2 divided by 3 is 162. So I believe that in the 5th figure there will be 162 squares. Is the sequence arithmetic, geometric, or neither? I'm going to say that obviously we were doing repeated multiplication, so that's going to give us geometric. So I saw this as something that's multiplying each time. Maybe you saw it as adding, so then you would then explain that it's arithmetic. Explain your reasoning, again, because we're taking and multiplying by a constant. All right. And then lastly, oh no, we got 13 and 14, almost done. I'm going to erase this and then scroll down. All right. So we're looking at 13 and then 14, and we will be all complete. Oh boy. Simplify each of the expression below. Express your answer as simple as possible. So we just want us to simplify it. I'm going to pick 2 of them to do because these do tend to take a little bit of extra time. So let's just look at, let's do one with, well, our adding and subtracting both have common denominators. So that one should be actually pretty easy. You should just be able to multiply or to add straight across. Excellent. Oh, so let's look at A then. A's got a lot of good stuff going on. So with A, we want to take, and the first thing we should be thinking is we need to factor. Let's see if we, and it doesn't look like I can pull out any common denominators. So for this one, I'm looking at, this is actually a perfect square. X plus 4 squared. It's just one I know. You can take it and factor it the old-fashioned way. The top one is another easy one. Let's see, something that multiplies to 24 and adds to 10. That would probably be, let's see, 6 and 4. X plus 4, X plus 6. So then I'm left with needing to do the factoring on the top and the bottom remaining ones. So I've got my 5 times 2, which gives me 10x squared, over my negative 11x. So that's going to be negative x and negative 10x. When I put that back into my box, we've got our 5x squared and 2, and then I just found out negative x and negative 10. What they have in common here is I know that eventually over here I'm going to want to get to have a negative 2 up there. So, or a positive 2, so I need to have a negative 1 times negative 2. And then over here I can pull out a 5x, and it looks like just an x. And so over here we should have 5x minus 1 times x minus 2. Next, let's do that last one on the bottom. My x. So I'm going to have negative 30x squared and positive 13x. So it looks like we're doing 10x and 3x. Putting that into my box, we have 10x squared and negative 3. And over here we'll have a 10x and a 3x. All right. So again, let's say we want a negative over here. I'm doing something wrong. In order to make a negative 3, oh, I need to have one of these be negative. Shoot. Looks like I need to go back and try this again. So we know we need to have a positive 13. We're looking for something that's going to multiply to 30. Looks like I'm looking actually for a positive 15x and a negative 2x. As you go back and double check the work. Alright, so positive 15x and negative 2x. Over the top we can pull out a positive 3x. Over here we've got a 2x, pulling out a 5x and a negative 2. Oops, sorry, negative 1, my bad. So here we're going to have 5x minus 1 and 2x plus 3. Never mind that x that I put on the next one. Alright, and then we're going to take from there and we can simplify it down. So multiplying straight across means what stays on the top will stay on the top and what's on the bottom will stay on the bottom. So we want to cancel out any pair. So I've got a 5x minus 1 and a 5x minus 1. I have 1x plus 4, which will leave me with one more in the bottom. And everything else comes across. So we'll have x minus 2 times x plus 6 over x plus 4 times 2x plus 3. Don't feel like you need to take and multiply those out. I would just say leave them as they are. Alright. Lots of work. I understand that these ones take time, but they're really good practice because we just took a test on them, but I can guarantee that you'll be seeing them again. 14 says the graph of the line and an exponential can intersect once, twice, or not at all. Describe the possible number of intersections for each of the following graphs. Your solution to each part should include all possibilities and a quick sketch. So we've got a line and a parabola, two different parabolas, a parabola and a circle, and a parabola and the hyperbola. Okay, so this one, a line and a parabola. So how this can work is I would draw the parabola first. It doesn't matter which way you do it. We can intersect once, twice, or not at all. So if we want to intersect twice, that's really easy. This means it's going to go through. And it's going to intersect at 2 points. Once means we've got a tangent, and it's just going to barely touch that top one, or not at all. It'll just go right by it. But we've got two different parabolas. Where can they intersect? Once, twice, or not at all. So we've got our parabolas. We've got one parabola, so we want them to intersect once. That means, again, they're going to be tangent to one another. I'm going to have them touch at exactly one spot. They can intersect twice. Or not at all. And you can assume with all of these there might be arrows. Next we have a parabola and a circle. Once, twice, and not at all. I'm going to draw a circle first, and then draw my parabola. So my circle is going to be a rough sketch. So I got my 3 circles. It's going to intersect once, which means it's going to have to be tangent. So I'm going to have it just touch anywhere on the outside, just at one spot. It can intersect twice, which means it'll just go through it at any point, or not at all. And lastly, a parabola and a hyperbola. Oh wait, I cannot say that for some reason. So I'm going to start with my parabola. I think that one's the easiest one. Mountains. And then once, twice, and not at all. Once, maybe it starts at the top and goes forever. Kind of got like a vertex. Or it could start over here, and then it'll go through the hyperbola. Or not at all. So maybe we got one, starts up here, and goes on. You might have